Welcome to this video on how to design and model a cardboard box within Autodesk Fusion. My name's Ollie, I'm an Autodesk certified instructor, and today I'm going to be taking you through this modeling project. We're not going to be focusing so much on explaining each of the tools, but we are going to be using them and showing how you can use the combination of them to create your cardboard box. Now, we've done a separate video that's released on the channel very recently and is linked up here at the top and in the description, that goes through all of the sheet metal tools and the details about them. But today is really just about digging into a project and modeling this cardboard box using those tools. So as I said, we're going to be using the sheet metal tools within Fusion. So I'm going to go create a new design and go to the sheet metal tab within the design workspace. And the first thing I need to do is create a sheet metal rule for cardboard. Now I can find the sheet metal rules from the modify menu under sheet metal rules, and you'll see that Fusion has a number of sheet metals already inserted by default, but cardboard isn't one of them. So we're going to create a new one from, let's say, this stainless steel one, and I can enter in here the values that I want for my cardboard. So first I'll call it cardboard, and I'm based in the UK, so I use millimeters. So I'm going to make mine 1.5 millimeters thick, but I'll put the conversion on the screen, and ultimately you can choose whatever thickness of cardboard you would like at this point. Now the K factor is all about how it changes when it bends. Now for cardboard, because cardboard sort of scrunches up against itself and the outer end doesn't stretch when it's bent, it actually has a K factor of 1. Now, if you want to learn more about K-factors and what they are and how they work, we have a separate video on that is linked down in the video description and up at the top here now. Now, I can also change a few things in here if I want to. I could change my bend conditions, because actually the radius of my bend isn't going to be anything like 1.5 millimeters. So I'm going to make this way smaller, 0.2 millimeters in my case, just to reduce that bend radius, because again, it's all scrunching up with cardboard, whereas normal sheet metal has to bend and stretch in different ways. Now, there are lots of other conditions that I can change here for corners and bend radius and relief and things. I'm going to leave this for now, and if we need to adjust them later on, we will. So when I press save, you'll see that cardboard has been added to my sheet metal rules library, and I could apply that now going forward in any file that I have. I could also right-click and set it as default, or delete it if I needed to. At any time you can come back and you can edit this, so we could change things like the thickness or the K factor or any other conditions that you need to. So now that I've created my sheet metal rules, I can do a little bit more admin, because I'm going to use parameters for this design. And this will mean that we can easily update the width, height and depth of my box to match different situations that I might need a different sized box for. So we're going to go into the modify menu again and do change parameters. And your parameter table will come up, and we can add parameters for each of our major dimensions. So we're going to create one for box width, and I'm going to make that 135 millimeters. I'm going to do another one for box height, and that will be 60 millimeters, and a third one for box length, which I'm going to make 80 millimeters. So I've now got my 3 parameters that I need for the actual size, and I'm also going to add a clearance value, and this is literally just going to be 0.1 millimeters, but we might need to apply this in different situations when parts align with one another. So you'll see when we use this in the future. So now I can start modeling something. So I'm going to go create a sketch on this bottom surface, create a rectangle with a center rectangle from this central point, and I can now type in the dimensions that I want. So I can have my box width as one parameter and one dimension, and press tab to swap to the other dimension and do my box length. So I now have that rough shape of my box. And I'll finish that sketch. And now we're going to use the Flange tool to pull parts up according to our sheet metal rules. So I'm going to create a flange. And here I want to turn off chain selection, because if I try and select this now, it's going to try and create a surface on the bottom around this sketch. And we don't actually want that. We want to select 3 of these edges and then pull that up. And this is going to be our box height. Now you'll see here I have an option to change my sheet metal rule. Because I haven't applied one yet, I haven't created a component, we're creating a new sheet metal component as we go. So I'm going to change this sheet metal rule from steel, which is my current default, to the one that we created, cardboard. So when I press OK here, you'll see that my component has changed to be a sheet metal component. And we have our rule and some of our other document settings up here in the top, as well as our body that is a sheet metal body. So we've started with our rough shape. We've got 3 of the edges. So let's go ahead and create a flange on this inside edge to close out all 4 sides of my box. Now this distance here, again, is my box length, the parameter that we created, but we don't want it to join exactly. So we're going to negative in this box, the clearance. And I can now have a little bit of maths that goes on, where I have my box length but minus the small amount of clearance that we added on as a parameter. Now, something important to note here is that I need to set my bend position to outside. This will place my material on the outside of this edge and therefore outside of my box area that I've defined with my sketch. If I don't do this, it'll be cutting into the area that I've defined, and our box will actually be slightly smaller on the inside by the thickness of the cardboard. So we set this as outside and press OK. And we've now got all 4 edges of our box with one corner that is not connected because we need to join these together. And they can't be connected because we couldn't have a continuous loop of cardboard but still be able to have it as a flat pattern that we could manufacture on a laser cutter. So we'll come back to that inside edge and fix that in a little bit. But for now, we're going to do the first set of flaps on our cardboard box. So again, same tool is going to be creating a flange on both of these inside edges, but also at the same time, we can do these 2 at the bottom. And we can bring this in and we can assign this a value. So we could say box width, but I'm going to divide it by 3 to give it most of the distance across, because it's got 2 sides obviously, but we don't want it going all the way. Now the other thing that we want to make sure here is that at the moment the bend position is on the inside, and what that means is that it's bending inside its original end point. Now that's great in theory, but it actually means that our material is cutting inside our box's volume that we've defined with our parameters. So we're actually going to change this to be outside, and that will flip our material to be on the outside of that edge and ensure that we're not cutting into the volume that we've put into our parameters and specifically chosen. Now it should have done this on both sides, which it has. Great. So we're going to click OK, and we now have those 4 flaps on both sides going in on the under flaps. So now what we want to do is we want to add in the other flaps that go the other way on top of these ones. But before we do that, we have to adjust these end points slightly. Because we've put these other flaps outside, they are higher up than our ends here, which is absolutely fine. But if I wanted to try and do a flange of this inside edge, I would either end up intersecting them directly or being inside them. And we don't want either of those. We want them to be above. So what I need to do first is I need to extend these upwards and then add my flange on afterwards. So I'm going to use the extrude tool here, and you could use the offset face tool as well if you wanted, but I'm going to extrude this surface and that surface, and I'm going to do it up to an object, which will be the top surface of my current flaps. But then I'm also going to offset that slightly by my clearance. So that'll mean that we go ever so slightly above that top surface by our clearance value. And that means that when we do our bend and our flange for the next flaps, that clearance value will be between the two surfaces. So I'm going to press that OK. Now I need to do the same on the other side. So I'm just going to rotate around and do that again. So extrude on these two object, top surface, and add the clearance in as my offset. So now I have two surfaces that are slightly higher up than these bends, and I can use these to flange from. So again, for these top surfaces, we're going to flange these inside edges, and we'll do it on both sides because we may as well save time. And we're going to pull these in. And this distance here is going to be our box length divided by 2 because it's going halfway. And what you can see, it is dividing by 2 slightly. There needs to be a tiny gap in the middle. So actually I'm going to add brackets either side of this, or parentheses if you like, and minus my clearance value to add a tiny gap that goes down the central point there. So these are now two separate flaps that we've got. So I'm going to click OK again. Well, before I do that, let me point out that the outside edge, okay, we've got our bend position on the outside. And again, that means that we're going up and over the original flaps that we had because we extended these edges upwards. So click OK. And we've now got a fully enclosed box that has all of our edges and flaps completed. Now at this point, we're going to check that this unfolds successfully. Something that's always worth doing as you go through is unfolding parts every so often, just to make sure that there are no errors or anything going on. So to unfold it, we're going to go Modify, Unfold, select any stationary edge, and you can see that is successfully at the moment unfolding. So I'm going to cancel that, we're good to go, and move on to the next step. So that next step is joining one of those corners. You might have remembered at the beginning, we had this corner here that wasn't bent, it was just sort of touching. But at the moment, they're not actually connected, so this would be a very weak corner for our box. So we're going to add in a tab that goes across the inside of here to fix it in place. Now I'm actually going to start with a section analysis to see what we're doing. So go section analysis, select this outside part, and just cut it in there. Press OK. And you can now see the inside structure of our box, but more importantly, we can see the inside part of that corner to see what we're doing. So I'm going to create a flange on that inside corner there, and we're going to pull it in. Now at the moment, we can't really tell what's going on there, but it's on outside, and we actually want this to be on the inside surface. It's overlapping and intersecting with our current cardboard box shape. So I'm going to change this to inside, and you'll see that it's coming inside of that face. Now this does mean that we are ever so slightly cutting into our volume, so I'm not going to make this go too far. I could also, if I wanted to, adjust this from a full edge to being only part of this distance. So instead of being full edge, I could do, say, symmetric and bring it down to only have a small tab. Or I could, if I wanted to, do two sides and have one tab at the top, up there, and then with the sheet metal tools, we have all the same tools as all normal. So we could pattern this down or mirror it across the other side to have multiple of these tabs. And when you do that, it will automatically apply the bends and the sheet metal rules as you do it. Now I'm going to leave this on full edge because I think going along the full side and just making it shorter will work best. But something else is we want to check that these corner conditions are as we want. At the moment, these are looking pretty okay, but sometimes you might find, especially if you're doing weird parts like cardboard, that you might need to override rules and adjust your bend radius or corner radiuses to change these from round corners to tears or other types of shapes. In this case, because our material is so thin, it's not really causing any issues, but it's just worth checking when you're doing it. So I'm going to click OK, and we've now got that inside edge that has come in on that part. So I'm going to finish my analysis to go back to my whole part. You can see that bend is now appearing on that outside edge there. And we now have a completed cardboard box shape. So let's now take our box and go to manufacture it. Now we've already seen that we can unfold it. We could do modify, unfold, unfold all bends, and create an unfolded version that we want to use. And we could put shapes into this. We could put holes or specific rectangles that you need onto this shape if you want to. You could also laser etch an entire pattern onto it if your company has that sort of branding. But actually, a fold and a refold aren't very useful from the manufacturing point of view. We want something slightly more permanent. Instead, we're going to create a flat pattern. So I'm going to go create flat pattern, select any stationary face, it doesn't really matter, and click OK. And it will create this flat pattern of our box. Now you'll see that you have all your bend lines in here that you can use if you need to. But this flat pattern is independent of the original file. So you can make changes in here that'll just be to this 2D version and not apply to the 3D version. From a manufacturing point of view, we have two options. You can either manufacture it directly from within the manufacture workspace of Fusion, or we could export this as a DXF and take it into another manufacturing solution that comes with your laser cutter or something like that. I personally prefer using Fusion. It's much more integrated, but if you do want to export as a DXF, you can do so using this DXF button at the top. You can also get it to convert the splines, if there are curved parts, which in this case there aren't, into polylines that'll make it a lot more compatible with most DXF files. But for me, like I said, I prefer the manufacture workspace in Fusion. What it means is that when we change our design, if you use your parameters to update the size of your box, you don't have to go through and update all of your manufacturing toolpaths. You can just regenerate them and it will automatically update and you can send it straight off to your machine again. In fact, let's do this. So you can always, don't forget, change your parameters. We set this up parameters. So I could change this and say that actually I want my box to be way longer than it was. Let's make it 180 millimeters instead. I could also make it wider. I could make it 150 wide to make a much more shallow, long box. And this will always update everything because we've used parameters in all of our dimensions, or we've used the toObject option. Now, when I do that, you'll notice my flat pattern has become out of date with the little triangle, warning triangle. So I can right click and update flat pattern, or if I just activate it, it will automatically update. But now my flat pattern has the new dimensions and sizing that I've just told it that it needs. So that ability to update is so useful to be able to take into the manufacture area. So let's do that. When I go into manufacture, within my models drop down on the left hand side, I have my two options for the flat pattern and for my original part. So in this case, it's automatically pulled through the 3D part instead of the 2D flat pattern. And I can swap it to be the flat pattern instead, because that's what we want to actually be manufacturing. And what you'll find is that once you've laser cut it or cut it however it is that whatever machine you're using, you should be able to assemble this perfectly, where all of the bends, because the K factor we put in, should fold as expected. It all should line up, and you might just need a little bit of glue on that inside edge and some tape to go around the top just to fix it in place. If you really wanted to, you can model that tape. I did that on this design here. I just modeled some tape using the surfacing tools, put on a decal on the outside edge, and then you can go into the render workspace and start a render of that part if you want to as well. So there's endless possibilities of what you can do here, whether it be making a cardboard box to go into your render, or it could also be creating your cardboard box for an industrial purpose because you need to create your own cardboard boxes to fit the products that you're designing and manufacturing. So there you have it, one cardboard box designed with the sheet metal tools within Autodesk Fusion. If you enjoyed this video, we really appreciate it if you give it a thumbs up down below. Please post any questions that you have into the comments or on the Autodesk community. And we'd love to see you as you create your cardboard boxes on the Autodesk gallery, posting the ones that you create. We've got loads more videos coming out, including our other video on the sheet metal tools, and that one's not so project-based, but is more about each of the tools within sheet metal and what all the options are within them. So make sure you check that out as well if there's anything that's unclear here. Other than that, I hope you have a great time creating your cardboard box, and I'll see you in the next video.